So what I was saying is each time you draw a line, I do want you to like double check that line. Don't wait till the end to check your answers. Double check as you're going. So what I mean is once you had drawn the 70 line, I want you to just quickly scan out here. Did any 70s sneak into the spot they don't belong? And this one looks great. You would then double check to make sure everything on the inside was bigger than 70. Also true. Then when you get to the 80s, it actually makes it easier because you just have to quickly look, is everything in here between 70 and 80? These look great. So this looks great until we get to the 110. And this is what a lot of yours look like. It is weird when there's only those two numbers and you got to connect them up. And especially after what we did the other day where there was two peaks, it got a little weird here. But when you had checked this, the same thing still applies. Is everything on the outside of this 110 less than 100? There's that 112. That 112 cannot be socializing with these ones that are less than 110. So to solve this problem, I mean, this part was right. This line right here, you don't want that 109 hanging out, but you would have just gone around that 112. So you did need to include that 112 on the inside of your circle. So almost everybody struggled with the same thing. So this was not unique to this one paper. I also wanted you to double check, did you do this down here where you left this loop open? It had to go to the edge of the paper. It is illegal to draw a line under here, even though it might look just like that. But we literally have no idea. There might be like a row of 72s or 78s down here. We don't know what's going on off the map, so you can't draw a line like you do know what's going on. So this is literally perfect. Is that what yours looks like? I was telling my students in my other class, so thank you, Liza. These ones that I had to do yesterday and the one that we did 2 days ago, these are harder than any of the Regents is going to ask you to do. So they'll never just have you start from scratch. But I wanted to pull up an example of one that the Regents. So this is the January 2024 Regents exam. So the one they took last January. And here's an example. So in Earth Science, we have an answer booklet and then a question booklet. So the question was here. Base your answers to 72 and 73 on the topographic map on your answer sheet and your knowledge of Earth science. The map shows elevations recorded in meters. Some contour lines are shown. Point A is the location on the surface. Question 72 is, on the map in your answer booklet, draw the 30-meter and the 40-meter contour lines. Extend both contour lines to the edge of the map. Then they give you the map on the answer key. So you can see that they already did a whole bunch of lines. They tell you the interval is 10 meters. So they did the 0 line. This would be a 10 line. This would be a 20 line. And they wanted you to finish off the 30 and the 40 line. So it's a lot less numbers. So it's not, and it's also not starting from scratch. When they already have one here, if you remember the rules that the lines are parallel-ish, this is kind of like a guide to you. So here's the 20 line. The 30 line will look a lot like the 20 line. It'll follow the same pattern. Same with the 40 line. So what I had you do last night was way harder than what the Regents is going to do. But if you can do that, you can do this no problem. You okay with that? Yeah. You can thank fourth period. They were all about doing these lines and they're like, can we do page 21? And I was going to give you different homework, but they wanted to do that other one. So that is going to be your homework, page 21. I'll warn you right now, it's ugly. There's a reason I didn't give it to you to do yesterday, even though it was the one that came next, because it's hard. But I don't want you working on it right now, but you will have a good 10 minutes at the end of class to get started on it. So I want to go, I guess that would be page 23. We were going to finish off page 23 and get started on page 24, and I was going to have you do page 25. We'll just do 25 tomorrow in class then. So like I said, though, 21, that one is rough. So if you're struggling, if you get it wrong, don't stress too much about that one. It's not a huge deal. So we're here. So like I was saying, I don't remember if I said this the other day. The Regents is going to make you do a bunch of stuff with these maps. So like I said, the first thing they're going to do is make sure you can draw them. Then once you draw them and have a map, they're going to ask follow-up questions. Like this one on here. Question 73 on last January's test said, state the possible elevation in meters at point A. So point A is listed over here. It's not on a line. So you have to be able to read these maps. And I'm pretty sure you guys could probably figure that answer out right now already. But let's go through some of the other stuff that they could ask. So starting on here, the first thing I want to look at is the map scale. This is where I thought you guys had known this already, but I think something happened in your 6th and 7th grade years because of COVID. And I think a lot of you missed this stuff about maps. So that's what we're going to make sure you got now. Starting off, do we know what the map scale is and what it's for? The thing right there, yes. If you do not know that this is the map scale, please label it now. Some of you did know that, so you don't need to label that. What do we use a map scale for? Let's label that right now. Measures the distance between two locations. Measures the distance between two locations. So if we had a map of Western New York, you would use a map scale to perhaps measure how far apart Springville is from Yorkshire. What units would you measure that in? Or what would, if you were for real doing it? Yeah, us in New York, in the United States, we use miles. So by the way, this will be in miles. Do you guys know how to abbreviate miles? It is MI, not just M. I cannot emphasize this enough. If you incorrectly abbreviate a unit, I have to mark it wrong. So if you mean MI, but you only put M, I don't care that that's what you meant. I have to mark it wrong. If you're not 100% sure of how to abbreviate, don't. Just write out the word miles then. So I asked, what would we use in real life? We would probably use miles. Since this is science, we do often use kilometers. The Regents will use both. So always check what the label says. So miles or kilometers. And again, do you guys know how to abbreviate kilometers? Yep. Again, if you don't know, write it out. All right. A contour interval, we already should know what this means, but if you don't remember, flip back and double check. What is it?
I know what it is, but I don't know how to say it.
So what was it on these maps? What did you have to do when we were using a contour interval? It's what you go up by or what the lines count by. So either one of those will work. Often the map will kind of be like what I have here. Notice in this one, they didn't put a little note of what the contour interval was. I do think they would have had to label at least one more of these, like if you could just slap in 100 at that one right there. They would have had to label more than what was labeled on here. But knowing that it says 0 here and 100 here, can you guys figure out what the rest of the lines are equal to? So how'd you figure it out? What'd you do? The map scale actually doesn't tell us what they count by. That's measuring how far apart two places are. So what did you say? How do you know it went up by 20s? What'd you do to figure that out?
The lines say just 100 and divide.
Yeah, that, math. Ew, no math.
I don't know.
Yeah, no, guys, no math. We avoid math in this class literally as much as possible. So what did you really do? You tried, right? Is that like what you mean? Did you just try to see what worked? Yeah, that's what I do. You know how like when we had to do graphs and you weren't sure what to label the lines, but up, it's the same deal. If 0 is here, by the way, 0 is also here. How do I know that this is also 0? Because it's the same line. And then I just try. Well, I would try, obviously I can't go by ones. There's not 100 lines. So I'm going to try tens, 0, 10, 20, 30, 40, 50. Tens don't work. So I need something bigger. So it's 0, 20, 40, 60, 80, 100, and then 120 over here. So the contour interval is what they go up by. So it's really how high the mountain is. What units are the contour intervals in? Meters. All right. So in this case, they are in meters. Do you know how to abbreviate meters? Just plain old M. This is why it's so important that you know that miles is MI, because if you put just M, that's meters, and that's a whole different label. So they're not equivalent. Now us in the United States typically use meters to measure the elevation of a hill or a mountain? No, what do you think we use around here? To talk about how high Kissing Bridge or Holiday Valley is. What? Feet. And that's FT. It can be lowercase or uppercase, not important for this class. So by the way, if you're not sure what the lines go up by, the scale will always be labeled, whether it's kilometers or miles. The lines go with that. So in this, what I mean is if the scale's in kilometers, the lines go up by meters. If the scale is in miles, then the lines go up in feet. So we stick with the same group of units. All right, direction of the stream flow. There's a stream here. This is supposed to represent a stream. By the way, pretend that that arrow does not exist. So I'm covering it up. So there's my stream or my river or my creek, whatever you want to call it. And we need to be able to tell them, is it flowing north, south, east, west, northeast, northwest, southeast, or southwest? How can we tell that from these maps? What do we know about rivers? Rivers flow downhill. Can you tell, or you should be able to tell from this map which way is downhill? How can we figure that out from this map? What do we got to look at? Okay, we got to look to see which way is going towards 0 or which way the elevation is going down, but there's no labels up here. But there's no numbers there, Trinity. Up here by the river, there's no numbers. Follow the lines. That's what you meant, right? Yeah. So I just wanted to point out, even though there's no labels up here, there's a label here. Follow that around. This one is 0, 20, 40, 60, 80. So which way is this river flowing? North. Again, so direction of stream flow. There's going to be 2 bullets here. So you have to don't write super big. Rivers always flow from higher to lower elevation. So you can tell that from looking at the actual lines. So rivers always flow downhill, higher to lower elevation. There is another way of telling, and I'm actually going to show this one here. This one shows it more. So there's a river here. So, well, it's actually called Cedar Stream, and I'm going to say that this isn't labeled an ocean. Let's call this a lake. Yeah, you guys don't have this, so. On this map here is this stream. Now we can use the elevation. Here's the 0. We already had figured out that that would have been 10 and 20. So we know that this stream is going this way. What's another way that we could look at this map and figure out which way it's going? Do you guys notice anything about the river? Take a look at that river and see if there's something you might see there that's kind of branching. It is branching off at the bottom. That might help. You're absolutely right. That's a delta. It is forming that triangle shape. That definitely would help you. There's something else too. We already talked about that, so it's going downhill. Yep. Yeah, well, not kidding. It's true. What do you notice about the river and the contour lines? They do intersect, and what happens where they intersect? You guys picture rivers in real life? Any river, creek, stream. You got one in your head? Why is that not working? Got a river, stream, or creek in your head? If you don't, how about this? Let's all picture over between Tim Hortons and Clesboys, where the Cattaraugus Creek flows. Can you picture where I am? What do you have to do to get to that stream or river?
Go down.
You have to go down. Picture a different stream or a river. You gotta go down. Even if it's just a little tiny stream in your backyard, there's always a little dip. Rivers carve out the ground underneath them. So the Grand Canyon used to all be level until the Colorado River came through and dug a hole through it and made the big, beautiful Grand Canyon. Anytime there's running water, even if you left your hose on in your backyard, and you left it that way for a long time, what's it going to do in the backyard? It's going to create a little river, a little downward path. Rivers mess up the shape of the land. So every time the river crosses the land, it is going to mess up the contour line. So see how every contour line bends a little bit? So see that bend? And even in the one in your notes, which isn't as good, see everywhere that river crosses the contour lines, like here and here and here and here, and even a little bit there. See how the contour lines kind of bend? That's because the land is being messed up by the river. They cause it to go down. So the other way to figure out which way that the river is flowing is that water will flow out of the bends in the contour lines. So if you have a bend like this, the water is going to come out of the bend. The regents will ask, I'm surprised it wasn't even a question on here about which way Cedar Creek or Cedar Stream was flowing. They would ask which way it's flowing. So in this case, it would be southwest. And then they're going to do a follow-up question as, how did you know? I only want to do one more vocab word and then we'll quit. Steepest section. And actually I lied. We're going to break this up into 2. Steepest section and gentle section. First of all, you guys know what I mean by steep? What would a steep hill look like? Show me. Good. What would a gentle slope look like? Good. Here's the ground. If I had a steep hill and a gentle hill, can they both get to the same elevation? Yeah. So here's an elevation I want to get to. Here's a pretty steep hill. There's that's actually not a great example, so let's pick a different spot. That one was too obvious. How about that? Got a steep side and a gentle side. They can both get to the same elevation, but what's the difference? One's going to take a longer distance. The gentle side, to get to the top of the hill, you have to walk and 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 walk, and finally you're at the highest spot. With a steep slope, while that walk might be harder to do, you're walking less steps to get there. It's less of a distance. Can you tell from looking at this map which side of this map is steep and which side is gentle? You think you can? How about the rest of you? You should be able to. Yeah? What about this? First of all, point to the side that's steep. Okay, most of you are pointing. Sorry, I'm backwards. Pointing over here. It is the steepest side. Let's label it. Steep, which makes this side gentle. What is it about the steep side that made you guys notice that that was the steep spot?
Oh, I really.
Steepest section. Lines are closest together. When the lines are close together, which is what, so it just says lines are closest together. You can't see it. What it means is to get from the 0 to the 20, you only have to walk a couple steps. To get from the 20 to the 40, just another step or two. 40 to 60, just a step, versus over here, to get from the 20 or 0 to the 20 is quite the height. Going from 20 to 40 is a huge distance. This is going to resemble this, where you have to walk quite a ways to increase your elevation. So over here, gentle section, this is where the lines are far apart. And I am sorry, I literally messed up. I want to do one more, and that's a benchmark. And then we're done, I promise. You guys take a benchmark test in ELA, right? Why? To see your progress. Or in other words, I like to say to see where you're at. If I gave you a benchmark, it'll see what you've learned so far in my class and what you still have to learn. That's what a benchmark is in this case as well. It's to see where you're at. It will say, so this is a benchmark here. It's labeled 123. A benchmark states your exact location. And so your exact latitude and longitude, as well as your exact elevation. So it states your exact location as well, and you can just say right? And your elevation. If you put as well, it's fine, but makes more sense as and. So a benchmark, and I happen to have a replica of a benchmark. It is this literally like a little disc like this that they put into the ground. This is a little smaller than what they are, but this is what they look like. So this is one from the Grand Canyon. In real life, it would not just say Grand Canyon. I don't know what NP stands for, but South Rim, that under here would also be the exact latitude and longitude of the point. And then it tells you the exact elevation at this point is 7,120. And these are put into the ground onto concrete little stakes that can't be moved so that you know that some scientists went there and measured that exact elevation. So right there is 123 feet above, or in this case, meters above sea level. It's just there for precise and to help you see exactly what's going on. So that's it for the notes for today. We'll pick this up starting tomorrow at the beginning of class, but you guys are welcome to get started on your homework, which is page 21. And like I said earlier, it's ugly.